Hi, this is the next video, and I'm going to go over question R3.2, and this is a great review question. It's again in our book on page 202. This is what the page looks like, and it's called Penguins Diving. So let's do it. It explains in the video, there's no picture, but we're just going to kind of make one to help explain. It says a study of king penguins looked for a relationship between how deep penguins dive, so depth, and how long they stay under, so that's the duration. For all but the shallowest dives, there is a linear relationship that is different for different penguins. The study gives a scatter plot for one penguin titled The Relation of Dive Duration, Y, and Depth in X. Duration Y is measured in minutes, and depth is measured in meters. Okay. The report says the least squared regression line equation is y hat 2.69 plus 0.0138x. Okay, so that's everything I've gotten out of the problem. And I actually want to clean things up here and just review overall. So again, this is the explanatory, this is the response because they told me. They said this is the x, this is the y. I know to make dots going up because this is a positive slope. Okay, now it doesn't look like a very big slope. I also noticed the y-intercept is somewhere at 2. Okay, so it's basically at 2 and it's going up, and we don't think it's going up a whole lot. There's not a lot of slope there. Okay. So if this was a question where we had to give a description, we would have to say what y is in x or rewrite the problem. So y is your dive duration. And I'm just going to be a big hat. And then you have 2 point, and that is in minutes. And then so this would be minutes if the depth is 0. So that's interesting. Apparently I'm underwater for 2.69 minutes, even though I haven't gone any distance underwater yet. So we're gonna get to how sometimes the y-intercept has an application and sometimes it doesn't. But at least to get my dots, that's where I need the intercept to happen. And now for x, that's my depth in meters. Okay, so here we go. Here's my least squared regression line equation. And the first part of the question says, in part A, so in part A, what is the slope of the least squared regression line interpret? So the slope would be, okay, and if I wrote that on a test, it's not enough. I want to go to my script, and again, I'm just going to plug everything in. So my slope means each additional x label, so each additional meter of depth, my y label, my dive duration will, and my script requires me to say increase or decrease. So since this is a positive slope, I'm going to say will increase by, and there's my label, by 0.0138, and I want my y label. So that is minutes. So let's just wrap our brain around that for a minute. So for every extra meter I dive, and I'm a penguin, then my duration is going to go up by a certain amount of minutes. And I think that that makes sense that the slope is positive. So the deeper I dive, the longer I should be underwater. I think that's reasonable. Now it says, and I want to add something. Each additional meter of depth, my predicted dive duration, right? These are my predicted dive duration will increase by. Okay, looking good. Now the next part of the question says, Does the y-intercept make any sense? If so, interpret. And so I kind of touched on that. Does it make sense? So the y-intercept is equal to 2.69 minutes. So that would be duration underwater at depth 0. So no, that doesn't make sense. Because I'm not underwater yet. So how can I be underwater when I haven't gone under the water yet? It doesn't really make sense. Sometimes it makes sense, sometimes it doesn't. Okay, we press on. What would C be? Okay, so the next part of the question asks, according to the regression line, how long does a typical dive to depth 20 meters last? So now, 200 meters last. So now I can plug this in and use my predictometer to predict how many minutes of duration that would be. And so when I plug this in, my y-hat ends up being 5.45 minutes. Okay, hopefully you're comfortable doing that. And again, the last part of the question states, suppose that the researchers reversed the variables using x as the dive duration and y as the depth. What effect would this have on the correlation? So we discussed in class, the correlation is how close the dots are to the line. So if I think about this, let's say that's my least squared regression line. I could trace this, still have my dots here. And what they're saying is, what if I flip-flop that? Now notice a pretty flat line, when I flip it, would actually have a much sharper slope. But you can see my dots bleeding through here. My dots are the same distance from the line, even when I flip. So when I flip the x and y, so that's depth and duration, if I decide to put depth here, duration there, yeah, it affects my slope, but it doesn't really affect the distance the dots are away from the line. Any of the residuals should all be the same. And since R is my residuals, made up of my residuals, it shouldn't change. So let's write out what they gave us. If the variable, going to answer the question, if the variables are reversed, the correlation will remain the same. However, the slope and the y-intercept would change. Okay, so let's think about that for a minute. We definitely explained why the slope would change. Wow, okay, look at how the y-intercept would change. In fact, the y-intercept might even be negative now. So look how my slope before was positive, and if I flip this, my y-intercept might even be negative. In fact, we know the y-intercept is going to change because the y-intercept is going to change from minutes to meters. So the y-intercept definitely is going to change. The slope is definitely going to change because the slope is going to be rise over run, how many minutes over how many meters. If I flip that around, it'll be the change in the meters over the change in the minutes. To write that out, again, slope is the change of the y over the change of the x. If I reversed it, now it would be the change in the x over the change of the y. And that is mathematically something very different. Thanks for joining me. Good luck on the test Thursday.